Good morning and welcome back. Section 11.1, Day 2, Parabolas with Horizontal Axes. So here we are. First of all, the equation, as you can tell at the top, subtle changes. X squared is now y squared, y is now x. However, everything else is going to be the same. Our p is still 1 over 4a, a is equal to 1 over 4p. Our focus and directrix are going to move left and right of our vertex instead of moving up or down. And you can see from the pictures, the value p dictates whether it opens left or right. Graphing wise, if you remember the 1a, 3a technique, it's going to be the same. We're going to find a, but instead of moving left and right one unit and then up and down using a, we're going to do the reverse. We're going to move up and down one unit at a time and left or right depending on a. So we're going to graph number 1, y equals negative 8x, and we have 4p is equal to negative 8. So p is equal to negative 2. And I need my a, which is 1 over 4p still. So a is negative 1/8, which means 3a is negative 3/8. Set up my axes. My vertex is at 0, 0. First point, I'm going to move up 1 and to the left a units, which is negative 1/8. I'm going to go up one more and move 3/8 to the left, and if I put the two values together, I've moved a total distance of 1/2 of a unit. And I'm going to reflect over the x-axis and connect the dots. And here's our first horizontal parabola. Some things I'll expect you to do is give me the ordered pairs for each, so pay close attention to what you're graphing, and it's a lot easier. And the bottom ones are the same, except your y values change signs because we're now below the x-axis. And we go back up for p. P is going to be the direction to get to my focus, which is capital F, and it will be at negative 2, 0. And going back to red, here's my directrix back here on the right side, and it is a vertical line, so x equals 2. All right, round 2. We're going to divide away that 4, and I get y squared is equal to 1/4 x. So we get our p value. 4p is equal to 1/4. That means p is equal to 1/8. Excuse me, 1/16. There's one mistake today. And our a is 1 over 4p, which ends up being 4. And that means 3a will be a whopping 12. So when I make my axes, I'm going to have a lot of left and right movement. So I'm going to count by 4s. 4, 8, 12, and then this will be at 16 at that point. And going up, I'm going to space them exactly the same, but I'm going to count by 1s this time. And I'm just labeling it so you can see that I'm counting by 1s vertically and counting by 4s horizontally. Vertex still at 0, 0. This time I'm going to go up 1, right a, which is a distance of 4. Again, remember, we're counting by 4s. I'm going to go up one more and go over 3a, which would be a distance of 12, getting me to the point 16, 2. This is 4, 1, and I'm going to reflect. So if we had made our graph to scale, or you graphed it on your calculator to check your answers, it would look a little different. Let's see, so 16, negative 2, and 4, negative 1. Now my vertex is 0, 0, so my focus is really close, 1/16 of a unit, and my directrix is 1/16 of a unit behind it. I'm just going to write the equation for each. There's x, and my focus is at, let's see, 1/16, 0. I'm going to call it quits on this video. I'll come back and do example 3, and then the examples on the back side of writing equations. We should have 2 videos total. Have a good one.